Welcome back, students. So in this video we are going to study about the applications of dimensional analysis. Why we are studying about the dimensions, so that's we are going to study now. So there are three main applications of studying dimensional analysis where we can use this technique. So dimensional analysis is helpful to convert one physical quantity from one system of units to another, like from MKS to CGS or CGS to SI system. So we can convert a physical quantity from one system of units to another by the help of dimensional analysis. Second application is that we can check the correctness of a given physical relation. Means if we have a physical relation or an equation, we can check by the help of dimensional analysis whether the given relation is correct or not, right? So this one is the second application of dimensional analysis. The third one is that by using dimensional analysis we can derive a relationship between different physical quantities. So if we know how to use dimensions, we can derive a relationship between different physical quantities using the technique. So for applications we are going to split the video in three sections. In each section we will be studying one application of dimensional analysis. So for now we are going to start with the first one, that is to convert physical quantity from one system of units to another. So let's start with the first application of dimensional analysis, that is the conversion of one system of units to another. So it is based on the fact that the magnitude of a physical quantity remains same always whatever the system of units we are using. If I am using CGS system or I am using MKS system, the magnitude or the quantity will remain same for that physical quantity. So to understand this in a better way, let us consider two systems, right? System 1 and system 2. So I have considered two system of units, system 1 and system 2. Let U1 and U2 be the units of measurements. U1 and U2 be the units of measurements of physical quantities. I am writing here, these are the units of measurements for the physical quantity. Next we have N1 and N2 be the numerical values for that physical quantity. Numerical value is N1 and N2 and units are U1 and U2 respectively, and the measurement of that physical quantity is capital U. Physical quantity has the magnitude and it is represented as capital Q. So in both the systems we can write Q as N1 U1 and in second system it is N2 U2, but both these values are equal to Q. So the fact that the magnitude of this physical quantity remains same whatever maybe the system of units is, this is used to convert one system of units to another. Now let's see how this conversion takes place. So I am assuming that in system 1 the sizes of fundamental units of mass, length and time are M1, L1 and T1. So in system 1 I am assuming that these are the sizes of fundamental units for system 1, and for system 2 I am assuming these values be M2, L2 and T2. So we are assuming that M1, L1, T1 for system 1 and M2, L2, T2 for system 2 are the sizes of these fundamental units. Now physical quantity Q can be any general quantity, so I am assuming that the dimensional formula of Q is M A L B T C. Okay, so I just consider that the dimensional formula of Q is M A L B T C. Then in system 1, when I am talking about system 1, U1 will be M1A, L1B, T1C. And in system 2, U2 will be M2A, L2B, T2C. These are the units. So if I want to calculate Q in system 1 and in system 2, I have to multiply these U1 and U2 by the numerical values. So here I have N1, I have to multiply this equation by N1 and this by N2 to get the physical quantity Q. That means Q is equal to N1 M1A, L1B, T1C and is equal to N2 M2A, L2B, T2C. Now this means that N1U1 is equal to this, N2U2 is equal to this, and N1U1 and N2U2 both are equal and equal to Q. So Q is equal to N1 into this and N2 into this factor. By equating these two, we get N2. If we want to convert N1 into N2, suppose N1 was known and N1 was in the first system whose value we know already. So N2 we have to find, we can find N2 as N1 and M1 upon M2 A, L1 upon L2 B, T1 upon T2 C. So this is the main technique that we are going to use to convert physical quantity from one unit to another using dimensional analysis. Let's see how we can apply this in an example. So suppose I'm assuming energy of 1 joule and I want to convert that energy of 1 joule into CGS system. That means I want to convert 1 joule into ergs. Let's see how this conversion work. So I have 1 joule of energy and I want to convert it into ergs, right? This I have to do. That means my value for N1 is 1 and this U1 is actually is SI system. Okay, U1 represent SI system. N2 I don't know, I have to calculate, and erg means U2 represent CGS system. So we consider all these facts and take two sections, one for SI system that is given and one for CGS system that we have to calculate. So let's see. In SI system M1 we have M1, L1, T1, N1 in the first system. In the second system we have M2, L2, T2, N2, right? Value of N2 is unknown while value of N1 is 1 joule. This we have known. In SI system as well as in CGS system, we have to first we have to know the dimensions for the physical quantity having units joule. So the quantity that have units joule is actually energy, and dimensional formula for energy is M L2 T minus 2. We can calculate it by using the formula mgh or square, that is of kinetic energy, or potential energy mgh. By any formula of energy we can find these dimensions ml2 t minus 2 for energy. So now we know the value of a, b, c. That means a is equal to 1, b is equal to 2 and c is equal to minus 2. This we have to use in conversion. For m1, l1, t1 in SI system, this is 1 kg, length is 1 meter and this is 1 second. Okay, in CGS system mass is 1 grams, length is 1 centimeter and time is 1 second. Now we have to see which to which system we are going. We are going from SI to CGS. We are going from SI to CGS. So we have to change SI system into CGS. That means 1 kilogram has to be changed into grams, 1 meter has to be changed into centimeters. Bas, that's it. Now we are going to use our technique that N2 is equal to N1 M1 upon M2 A. So A was 1 L1 upon L2B, that is 2, T1 upon T2 C, that is minus 2. Now we have to substitute all the values. So N1 was 1, M1 was 1000 upon 1 power 1, L1 was 100 and upon 1 power 2, T1 was 1 upon 1 and this is minus 2. On solving this we get 1000 into 1, 2, 3, 4. That means it's going to be 10 to the power 7. N2 is equal to 10 to the power 7. So this is 10 to the power 7. That means 1 joule is actually equal to 10 to the power 7 ergs. Means 1 joule in SI is equal to 10 to the power 7 ergs in CGS. So this is the technique how we can use the dimensional analysis to convert one form of unit into another, to convert one system to another system. So that's it for this part of the video. In the next part we will be studying the second application of dimensional analysis. So till then, stay tuned. Thank you.